I want to establish something. If I know that these two triangles are congruent, if ABC is congruent to DEF, then what do I know about side AB? Raise your hand. What do I know about side AB, Emily? Okay. What do I know, Jonah, about side BC? And Bryce, what do I know about segment AC?
It's congruent to DF.
Cool. And if I have triangles that are congruent, then I know our corresponding angles are congruent. Am I blowing your mind, or is this just like pretty much we knew this? Pretty much we knew this. Okay, so the one thing that we are adding today, what do we call A and D? What kind of angles are they? Okay, true. Corresponding. A and D are corresponding angles. A, B, and D, E are corresponding sides. So we say that corresponding parts of congruent triangles are congruent. This is me trying to draw attention. Corresponding parts of congruent triangles are congruent. CPCTC. Okay, well now we're going to use it in a proof.
Is that a reason? Is that like it?
Oh, Bryce has a really good question. Is that going to be a reason in our proof? So this is what's happening, people. How about you turn to page 155 in your student journal. Keep out the reference sheet, but turn to page 100 and what did I say? Okay, that.
I would like to go on.
Really hard to get you your homework work time in class when you don't do the things I ask you to do.
We have homework every day.
Oh man. You are telling me that you want to spend the whole time in class doing notes and you want your entire homework to go home with you. Or you could just shut your mouths now and we could get through our notes and you could get at least half of your homework done before you walk out of here, maybe more. Okay, so congruent figures, we know, are the same shape and the same size. And if we have congruent figures, then our corresponding parts are also going to be congruent. Okay? And that's the whole premise of today. Okay? We need to prove our triangles to be congruent. Then we know corresponding parts of congruent triangles are congruent. If we have congruent triangles, then our corresponding parts are also congruent. Corresponding parts of congruent triangles are congruent.
Yeah.
Corresponding parts of congruent triangles are. Now you have this written down already on your reference sheet, but if you need it there, there it is. CPCTC stands for corresponding parts of congruent triangles are congruent. My shoes are really squeaky, sorry.
I don't hear. I hear them. I hear them.
They sound a little Dutch.
It's amazing how many people are writing things down. Okay. Now we are gonna go through 2 proofs so you can see how this works. Are you ready? Can you draw? We're not gonna worry about it. Okay, so here's our given. Our given information is that angle F is congruent to angle M and angle 1 is congruent to angle 2. What are you talking about, Miss Holman?
Wait, is there anything else with this buffers?
Okay, so this is what we're doing. You have this drawn. Seriously. Like we're writing a proof. You need room for a proof, right?
Lock in, brother.
Okay, so I'm giving you information about parts of triangles, but instead of proving that I have congruent triangles, I want you to prove that a piece of this triangle is congruent to a piece of this triangle. Okay, well, if I show that those 2 triangles are congruent, then we know all the corresponding parts are congruent. Okay, so let's first focus on proving our triangles congruent. So let's identify our given information. F is congruent to M and 1 is congruent to 2. Okay. So we have 2 sets of angles, bless you, are congruent. Raise your hand if you have an idea for how we're going to get these triangles to be congruent. Keegan, what's your idea?
Maybe AAS.
Okay, so you're saying that we can do this side and then we would have AAS.
Yeah.
Okay, now I have a question. In this triangle, is PL gonna correspond to PL or LP?
LP.
Okay, so PL is gonna be congruent to LP because of the symmetric property. So we know triangle FLP the rulers that I buy with my own money, you just decided to break one.
I didn't mean to. You just kind of, you know.
Like not even an I'm sorry,
Well,
not even,
I'm sorry.
I really want you guys to understand that the school does not provide us with very many materials. Most of the things that you see in my classroom, I buy with my own money, and I don't get paid a whole heck of a lot to just be spending money on 10 new rulers and 10 new calculators and 10 and 50 new expo markers every year. Like the things that I have in here, I buy. I've already gone through 80 pencils because people just take them and break them. You know how long it took me to go through 80 pencils at the high school? 2 years. I've gone through 80 pencils in 3 months. It's ridiculous. Ben,
When are we gonna get those like calculators?
I have them. We haven't needed calculators, so I haven't gotten them out for you yet. Okay. So we have FLP is congruent to triangle. MPL, is that what we decided?
Yeah.
By AAS. And since we have congruent triangles, then we know that these corresponding parts, FP and ML, are congruent by CPCTC. Okay, so Keegan just said it's like the same thing, we just added a step. Uh-huh. Nope,
So
that's,
After you get your congruent triangles, you just put that at the end.
after you get your congruent triangles, and you can say, okay, these corresponding pieces are congruent by CPCTC.
Wait, so we don't even really have to think, we can just like right after we get like the 30, we can just like put that.
Yes, Layla.
Seems like some easy points to me. Stop.
Okay, Layla had a good question. What if I threw a trick at you and I said FP is congruent to LM? You see what she's asking there, if this was backwards? Okay, we could say this because of corresponding parts, but then we would have to use the symmetric property. to get it to
Wait, so
figure out.
then when
Okay,
you-
it is really hard to answer questions when people are talking, okay? Jonah,
Well, I don't think I'm gonna be able to remember CPCTC. If I like have the, if I had like CCPTC, we can't write. Just remember.
Just right.
I think that you'll do enough proofs that you'll be okay. I'll get the idea. Paxton, did you have a question? No. Paxton did not have a question. Okay.
I'm just saying you change.
FP is congruent to
I'll remember
LM.
Would
Would it, if we change this to the symmetric property, and flip it, would we
I'll
use
remember CPC.
reflexive on this type of view instead of symmetric?
No, we still have to use that.
Yeah.
All right, let's go ahead and go to the next page and let's do one more proof together, just so we know we have it under control. So we're actually not doing any of these right here. I'm just gonna use this blank space, okay? So up in this space over here, I want you to draw this parallelogram.
The very next page, Bryce.
We're drawing parallelogram, MNOP. Like that.
I like making my.
Not yet. So I am giving you that MN is parallel to PO and MP is parallel to NO. So with the given information, Layla, now we can do that. Okay, so this is the information that I need you to write down. It'd be very helpful to label MNOP. We're gonna do a proof for this one. We're just using the blank space here, people. Just trying to be efficient with your materials. Okay, so MN is parallel to PO, so I marked it. MP is parallel to NO, so I marked it. And we want to prove that MP is congruent to NO. Actually, I want to prove that it's congruent to ON. JK. MP is congruent to ON. That would make our lives easier. All right, so, wait, what? We're going to together. Okay, with the given information, that's gonna be our first step. Right, I want you to identify one piece of information we can use from the set of parallel lines. With parallel lines, what do we need to look for? Congruent sides or congruent angles?
Angles.
Congruent angles. Congruent angles. So which ones are gonna be congruent? M, N, O, no. Here's our parallel line, here's our parallel line, and here's our transversal. It's pretty terrible.
NOM and PMO. Oh, I know.
Well, the parallel lines that I highlighted, we'd be talking about these right here.
That's what I was trying to say, I just did not say it.
Okay, so let's call them angles N, M, O, and P, O, M. Because alternate anterior angles are congruent. Okay, now we have this set of alternate interior angles from our other parallel line set. So angle PMO is congruent to angle NOM. Same reason, just a different set of parallel lines.
And then you can just do ML. How do you change the color?
Now, is it gonna be reflexive or symmetric? Okay, MO needs to be congruent to OM. So that we can say that triangle PMO is congruent to triangle NOM. Ben, what's our reason for our triangle congruence?
Well, based on the chart, I would say angle side and
Great, angle, side angle. So since our triangles are congruent, we know that these two pieces are congruent because corresponding parts of congruent triangles CPCPC are congruent.
Is there like anything you would ever